what will it be about here?
About military sector?
Okay.
Yeah.
Good. And I have things for that. We can talk about this.
Yeah, so for example, me, I'm working in university, technical university, and we are collaborating actually with Leonardo.
Oh, nice.
Company. Yeah.
Okay. Well, quite famous.
Maybe you can tell what you're manufacturing in Italy.
I'm manufacturing various. I have various things. So I'm manufacturing AI solutions. Basically, currently focusing on computer vision systems, which go from the camera itself, which is capable of running AI workloads, but it can be extended camera to an edge device that has compute capabilities. So you can have multiple cameras that connect under an edge device that have the capability of running some heavier load, and then extend this all of the way to a cloud system. And it's all a single pipeline. We designed the cameras also, we have the capability basically of selecting the sensors that we need. So the system remains all the time the same, but I need maybe high quality, lower price, night vision, high frame rates, or something like that.
Is it for drones or?
It's generic, frankly, because the camera system in itself does not change. Like on a drone, maybe I would focus on, let's say, color vision. Probably relatively high quality, not really very high frame rates, probably on a drone. But for instance, in an industrial system, there I would use maybe lower resolutions, not really that much high quality, but high frame rates. In some other places where I need to, count cattle, for instance, animals, I will want to have one of the sensors to be an infrared sensor, for instance. So, but in the end, it's the same.
So the colleague started this good question about whether scientists should be involved in military conflicts or should be opposed, or
I think there is a history, quite long history of having the military conflict being upturned to either one side or the other because of scientific innovation. So might be because of better weapons, or even on the other side, things that allow you not to have the conflict in the first place. So fast Fourier transform, for instance, that was invented during the Cold War to be able to run Fourier analysis, which is the frequency analysis, and it was required to have this faster, this faster Fourier, I think, allowed people to study seismic waves from nuclear detonations to be able to count how many bombs people had. You see, and that allowed, in turn, for another scientific approach to be discovered, which was games theory. Games theory that in the end resulted in the result of having Russia and the United States to talk to each other and decide on nuclear dearming. Because of the conflict resolution aspect that was discovered through game theory. So I think that it's necessary to involve scientists in the conflicts, not in the conflicts, hopefully not in the conflict part, but mostly in the research in the military. That's required.
And good point about scientists can get new ideas or options to develop weapons and things to make us more secure. And they should not communicate each other between, right? This was your point. Like two sides of conflict, and one scientist and second. And if they are sharing then information, it can not lead to competitive advantage for one side.
Yeah, but although at the same time, you see the results, for instance, from John Nash from games theory, well, that was something to be shared. You see, fast Fourier transform, the same thing. That was a result that had to be shared, and that allowed the best of the scenarios, which was the one of not having the conflict. So I think it depends. So on one side, you want to have the best defense technology that allows for the even to continue on the. Okay, it would be useful. I think it would be useful for other people, for people to know what are the results from game theory from Nash, to fully go through the conversation. But what I want to say is basically. To properly be a good entity, a good person, let's say, a fair person, you basically must have the sword but decide not to use it. That's like
you need to have a big sword to stop the other side to start using his sword.
Yeah, exactly. Because and that's one point. But be the one responsible enough to decide not to use it. In the end, though, the best possible scenario that you have is that is the scenario in which the two parts are collaborating. Because that's the best results that you have from game theory.
But if you, for example, I think with our scientists, they are working in this defense research program, and they have to publish publications freely, openly, as scientists have to share their findings. You know.
Yeah,
but for example, if you think about if the publication is completely free, it's completely open.
It's available for everybody.
It's available for Russians, you know,
for everybody,
and everybody, and that's I think I don't agree with it. I think we need to have a special database for I don't know NATO alliance or European Union alliance wide scientific community where they can share their knowledge. Because of this alliance is, you know, important to have, you know, like a closed knowledge sharing. That's very important. We don't want to share. I think give adversaries.
I think that is true, especially for those things that corresponds to the weapon part.
On the other hand. Scientists don't know often if this new thing that will be used as a weapon, right? I can imagine.
It's like public money. Like we are spending our public money into defense research, and then they will share with.
That's completely. That case is an issue. I must agree. Especially because a good amount of research that is done by universities in Europe is actually funded by China. Like you would be surprised in telecoms, for instance. I studied telecoms. I think 90% of the projects, at least in Italy, they are funded by Huawei, China.
Okay.
A huge amount of the communication networks are built with Huawei. I don't like it much. I don't like that much.
And there's an interesting moment that America is cut off Huawei once for all.
But some countries are doing that already.
Lithuania is following the same path. Really?
France also.
Okay.
Not completely,
Latvia.
Not Latin.
but they have a percentage. But Latvia has a good amount of its communication infrastructure made with MikroTik.
That's true.
Yeah, a really big part of the government sector is using MikroTik only, and
Yeah.
that's the only choice.
Yeah.
Yeah.
Which makes a lot of sense.
Yeah.
Yeah, I mean, you have one of the best, I would say one of the best telecoms producers in the world currently, and it would just be stupid not to use them.
This is pretty scary from my side. Like, how I know that Huawei is one of the biggest telecom manufacturers, right?
What?
Telecom manufacturers.
Yeah.
They manufacturing a lot of green energy transformers and inverters, something like that. And for me, it's scary.
Yeah, I agree. Every device, every computing device is in itself can be a router. So can act as a communication device. Especially in IoT solutions, basically, yeah.
It can have some tunnel or I don't know some
VPN tunnel.
connection that sends all the data to.
It is possible. It is a computer by itself. So, it is possible if you, especially with cloud applications, which is why I really want to. When we make products, we really want to avoid to have, to provide people. Although you have, this advantage of these cloud solutions, right? We really want to avoid the centralized cloud because for an ethics point of view, like I would not want to have cloud applications from a China manufacturer of a router of a solar inverter myself. And actually, we bought a solar inverter. It handed the cloud applications. We stopped the communications, found the protocol in order to be able to talk with it and have it isolated. Because yes, it is possible to just have a VPN tunnel and then you have a computer that is just connected to your Wi-Fi.
That works like a gateway to just entry. Yeah.
As long as you have connection to the internet, you can reach that. And
How do you think it's possible to bypass, like communicates right from satellite or something?
Well, if you buy routers like that and you're company, if you buy, see there's any fit there, they buy Huawei devices, okay? The protocols are very simple on those routers. What you can have as a Latvian company is your Latvian cloud. And cut the connection to the router, to the Chinese cloud, and replace your logging system. The logging system is pretty simple, The thing is, currently, if when you set it up with an easy alternative, which is the one that is already available. But the one that is already available is in China. I think also, frankly, competitively for a company, I mean, it makes sense also to have your applications. I understand it's a cost to develop them. Yet, I think information is one of the most valuable assets that people have, in general, like that humanity has.
Yeah. So continuing, discussion about like maybe further, about China. My thinking is, I don't know how you feel, but China is becoming the world leader.
Yeah.
All the technologies and research and AI, for example, DeepSeek, all these, the first drone taxis, it is in China.
Yeah.
And Americans go there and, try to copy. And my thinking is, NATO alliance is, a little bit shaky right now. Because of America is, wanting us Europeans to spend more money on defense, like burden sharing, basically.
Yeah.
And they don't feel that they are leading. They don't feel they are leading. They're trying, to control the world powers and everything. And then my thinking is, why not to, start thinking about like joining China or being, creating a new alliance together with China. I'm just speculating. I'm just thinking. This is my thinking. Because, we want to be with the strongest, with the most powerful nation. And NATO is the most powerful nation because of America. And America is, half of military power of NATO comes from America.
I think.
And maybe we should start thinking about China, but not with, Russia and all the other BRICS countries, which are like not very good countries, and I don't support it. But the one thing is that NATO is.
Yeah, maybe we can tie the rope a bit shorter.
Yeah, what do you think about this topic? Have you thought about it? China and America, like one hand China, one hand America.
From my opinion, maybe it's not popular, but I somehow agree with you. We as a small nation need to be friendly with a lot of on the other countries and stay positive. Of course, we need to be strong with our ideas and word and ourselves, but we can't afford to like barking around. We need to be friends with, but we doing it smart to not shoot in our own leg for the future.
The most important thing is making sure that at least between Europe must be very strong between each other, and that's the first thing. Then, of course, you need to, as you were saying, you need still to be selecting those alliances that resonate with your values, with your culture, because we are not China. We don't really work in the same way at all. So, frankly, we don't even function exactly like America. We're quite close, much more similar, if you wish, to America than China. But I think I don't know. Maybe I think a properly industrialized Europe has the definitely the potential to be fully independent without requiring extra power from the other ones. If, of course, we invest correctly in
invest correctly and together as a shared burden, right?
As a shared thing, yeah. Like the European, the European cultures, even if you take the ones that are most far away one from the other, I'm thinking, I don't know, Spain and I don't know, Serbia, which are quite far away, maybe one from the other. They're still way closer than the kind of culture that you would have in the United States or China. We all have this cultural, quite old cultural heritage. Our the cities with an old town centers. We all have this common way, of.
Common culture, common values.
Very close, but very simple.
It's not Chinese.
No,
and it's far away actually from Chinese.
And it's far from the logic of the United States with those very new things, empty settlements. The center of the city is a commercial center. Quite far from the Russian system, frankly. Although we're way closer by to a Russian culture. not saying the value of the government at the moment. I can't say. Let's not put that effort that there. Yeah, but anyway, further away from the Russian system, which is also similar. You know, you just have resources in a place, and that's where the settlement is, and it's quite basic.
Yeah, the Russian culture is they don't share the income or like their valuable resources with others. That's, I think it's one of the, I don't know, cultures like Europe and NATO don't support. It's like if you see like oil, gas, you know, these resources are also in Norway. Why Norway is so different than Russia? Russia is like it's very like concentrated on oligarchs.
Yeah, there's big corruption as well that slows down the process. And, everything is kind of expensive because of the chain takes away that money by the corruption.
I think is that
but we are so close, you know, we are neighbors basically. And everyone is saying like our neighbors will stay there for forever. You know, it's Latvia and Russia is like Belarus. We are all together, but we cannot. We are so different. Yeah, we are so different. Like if we're talking about Latvian people, of course there are Russians as well. So we have half, maybe like less. I would say 40% of Latvia is Russian speaking, and I don't know the precise details, but
there's plenty of countries in Europe that decided to get detached themselves from Russia, so there's something there, I guess. And I don't know. I would almost suspect that maybe that will happen again with some other parts of Russia, but I can't really say. I haven't studied that. I imagine that St. Petersburg doesn't like it feels. Has a culture that feels much more similar to the European one compared to what happens on the other side of Russia. But
the American rhetoric is always like I am researching defense spending. This is my dissertation. They are competing. They're always competing with China, other nations. Their intention is to be, you know, competitive and win. So winning culture. But Europeans are spending for defense because they are afraid. They're afraid. They are not competing. They are just afraid of war, and this is their intention. But
like we don't really want it.
How do you think what we as citizens or entrepreneurs can do to ensure security in our region, and what we should do?
I think we should invest more in defense. It's the right moment. It's basically if we don't, then we will open the doors for aggression. So we have to become stronger. And
there's that. I think there's that, and there's also the things that even do not go directly in military, which is make sure that the things that you develop, that you make, have independence in mind. So we've been standing with this quite a long time with our family company. We make routers. That's why I know that this much about telecoms. We make routers. We want to make sure that people can be independent of their router. It's the communication system. Communication system must be neutral as much as possible, right? So we do not stick to one provider. We want the customers to be independent from a provider. How do you get independent from a provider connecting to the internet? Well, you get more than one. Okay, you get more than one, you communicate on all of them at the same time. This allows you to not be dependent, right? How do you get independent on the electronics things that we have inside? Well, the system is not Linux, it's not Windows. It's a European system, right? That is kept bare bones, so that it just runs what it needs to run. It's a router, it just needs to communicate. How do you select the technology? Well, why do you have to be bound to either fiber optics or radiocom or something else? In the end, you're still solving the same issue as a router. You know, you want your communication to go on one side or the other. Therefore, those are just the lower level device. Select your lower level device. The rest of the communication is the same. It will go in, I don't know, in radio wave through one provider, in fiber optics through another one, is something else. Yeah, it can switch and do that in several ways. Am I going through the internet maybe to do that? Yes, but not a problem because it's separate channels. Therefore, as long as the internet remains an independent thing, well, which it is by design, then your comms are independent, right? And people cannot listen on them because you're breaking the communication on different paths. And yeah, so I think the logic of searching for the independent way of doing your things, or of focusing on making things through European stuff, that's already a big way to be able to flip off a country that decides to be to say, oh, mine,
Right. It sounds really complicated. Like a lot of people will not do or buy this expensive equipment or do extra steps to secure this, right? And they will do easiest things and be unsecure.
But you can provide the service. It's not an issue as long as it's part of the thing. The same way that you deploy a machine and which will connect to the cloud. Well, it's pre-configured to work with the 10 providers that are available there. It's pre-configured that if you plug the cable, it will find the cable has been plugged. It's complicated underneath for the development side, but the logic of it remains the independence, right? So. Yeah.
How about quantum? Do you think quantum communication?
So quantum communication is okay. Currently, what is being done in quantum is quantum encryption. When you talk about communication, so quantum resilient encryption. So it's an encryption system that do not actually require quantum computing to be able to be done. Its purpose is being resistant to quantum decryption. So quantum computers in the end are just computers that are capable to solve more complex problems than the problems that we're solving right now in mathematical terms. Because, I mean, very shortly explained, leveraging some quantum mechanics, so some specific physics, you are able to get more solutions, all of the solutions, let's say, by asking the question. So while a question in normal computing would, do a lot of iterations in order to provide you one answer, if in a quantum computer you may have the possibility of having all of the solution explored in the same question, in the same batch, and then you get the solution straight away. This allows to reduce a lot of the computation times for complex problems, right? So quantum encryption, quantum resistant encryption allows post-quantum encryption. That's how they call them. allows you to make sure that even for a quantum computer, it will be a complex problem to decrypt. So useful, not different than the previous system. It just keeps up. Yeah, it just keeps up. I think that, frankly, the first step for system to be secured is not really that of using the highest level of encryption. It would already be that of changing the damn passwords
Right.
and have them randomly generated, right, with the key phrases and multiple steps stored properly. Because if you have a quantum secure system, but your password is password,
1, 2, 3.
you kind of have like, okay, you have the best photonic system, but the password is still that. And unfortunately, from what we see, this is regular. And we've seen that in municipalities, we've seen that in military. so yeah.
So basically, you're saying that all genius things is pretty simple. Just change your password and
Start with that. Like we do need to start with that. Yes. Use key rings. Generate the passwords randomly. Have them in an application that stores your password locally, so they don't go around. Protected, of course, with a passphrase that you only know, but you see, at least they're not saved on some cloud of somebody else. Well, that's also maybe a problem. You see, a lot of people are storing their passwords in Google.
Especially.
Because it's comfortable, right? Yes.
Actually, a lot of companies running in the same way. They're sharing passwords in a Google Sheets or something like that. Whole company is working with some passwords, but they are stored.
I mean, at least Google has people from a lot of the world. It responds to US law, but it has people from a lot of the world. Therefore, they kind of focus on making sure that the data that is on Google Drive is actually encrypted. So if it's not you trying to access your data, then that data is encrypted. Although, a lot of people, a lot of companies would have their passwords in clear in a Google Sheet and then share with all.
Yeah. Everybody
with a link. That can just be scraped and found. And that's very dangerous.
ChatGPT is scraping all the files.
Yeah, ChatGPT is definitely scraping. Definitely scraping.
So basically, you can ask ChatGPT, what is my password?
But you see,
Google, he will find.
You see, in AI though, there's a lot of effort on open models, and the open models are actually very good. Like, open models are very good. They compete with ChatGPT and DeepSeek. They can be run on a local system or cloud system, but instanced in Europe, in some server in Germany, if you wish, or in some other places, or in some distributed cluster, not an issue. Distributed a bit of everywhere. You can put some in Europe, some in USA, some in China, in a distributed system, and you get back to your, being independent because you use all of them. Right? We personally are using, as a company, some, like, if I deploy an AI application, I will not deploy it with ChatGPT. I will deploy it with Gemma 3, for instance, or and there's Ollama. There's several Ollama models. We'll deploy it on a server. I will make it, a software that uses data to be able to, interact with my users.
With your data and
with my data locally, even not locally. It can be in virtual machine somewhere, but with my data. And yeah.
It's really powerful because I know that a lot of companies have a lot of data and they are managed. You can make analysis and predict some things, but it's not perfect. It's too much data. Too much data for everything. And with AI, we can get, with right AI, you can get the right information also.
I think it doesn't even have to be an extremely powerful AI. With the extremely powerful AI, it's more forgiving, so it's helping you more to handle your stuff. But it was already possible to do proper scraping, proper data recollection of unstructured data already with GPT-3, which was before the first ChatGPT. That would already be capable of that. The current Gemma 3 model can run on an NVIDIA 4090, okay? And it's comparable to GPT-4, ChatGPT, so like the latest one. A consumer-grade computer can do that currently. And with that, you can definitely scrape your emails in your company and have them in a structured data form. You can scrape whatever PDF documents that you have, maybe, and make them into a structured data form. Yeah. It takes some effort. It definitely takes some development. Probably some of those development will have to become, I believe, open source for it to be, for it to be accessible to people. Like, you can't have people that are not in the AI field have to deal with the AI development. You need them to have some relatively easy access to open source systems, so that a young-ish developer can find it on something like GitHub or equivalent. And have the platform available for themselves. Because if you lower that bar, then you will see more and more companies decide to have their local system.
From security side, it's just a system. Because I was scared about this black box. It's not AI, right? And
I think that AI. There's a problem in AI, which is the name AI. It's a huge problem. The name AI, artificial intelligence, comes from it's a marketing terms actually. Back in the day, artificial intelligence it was. Management systems, CRMs. Then it became expert systems. The intelligent system is the expert system that was developed on a specific purpose, and now it's learning algorithms and learning-based algorithms and. I think the correct terms, the actual correct term would be deep optimizers.
Because learning capacities.
Yeah, because in the end, AI algorithms, they are, statistical structures, formulas, really, made of logical blocks, let's say, and they use some statistical approach to reach an objective, which is an error function. An error function, you can think of that like the score in a video game. So you build the logical blocks based on the kind of operation that you need to work on. So there are logical blocks that are good at extracting features from a video feed, for instance, from an image. There are logical blocks that are capable of retaining memory from one iteration to the next one. there are logical blocks that are good at mapping concepts. So results in a space. That would be okay, which means separating concepts. For instance, there's logical blocks for more of that. If I need to make a computer vision system, I start with logical blocks that are feature extractors. You know, from a picture, it tries to get geometry. Geometry information, right? If there's an edge, if there's a point, if there's a blank space, if there's colors, if there's something like that, and that those kind of blocks will kind of say, okay, edges here, edges there, flat here, flat there, points here, color, that kind of color there, and it processes that in one layer. So your image becomes a new image of an image for the first kind of feature, an image for the second kind of feature, for the third kind of feature, etc., etc., etc. And you can continue doing that in multiple iterations, and what you get is continuously more increasingly complex increasingly complex feature extractors, right? Because you have all of the tree of feature extracting one after the other, then the feature that you extract at a very deep level is quite complex, and that's how a vision system is able to recognize a tree from a person. It's still edge detect at the very beginning, and then edge like that, it will start up becoming something like a geometry, and then a lot of geometries that kind of stay together. Then that's kind of part of an object, and then you continue deeper and deeper until you build objects. So at that point, it's a system that is just kind of at the level of edge detect, kind of at the level of feature extraction, kind of at the level of putting geometries together, kind of at the level of putting those complex shapes together, and then compositionally getting further and further and further. So you see, that will not be able to learn language. That is designed to learn image, right? So there is an understanding of how the logical blocks are made and of the process it follows, right? Then the learning part is only that of actually attributing the correct weights to this thing so that the features are extracted. But frankly, it's actually possible to look at a section of the model in any, do a brain surgery on the model and look at what is visible in a specific slice of the model. If I look at my computer vision model for video surveillance, at the very deep end, I see a map, black and white, of interesting objects. That's it. Interesting objects. So the things that respond well to being an object. So it can be intuitive. You just take slices. You can look at those. They're not fully black box, really. So yeah, and the learning, and most importantly, the learning is targeted to these scores. So the important thing is, of course, to have the structure of the model, but designing the scoring system. So for language, ChatGPT will have a score for making syllables, for making properly written words. It has a score for separating the concepts as far as possible one from the other, so that they are the most independent one from the other. Okay. Basically, synonyms will tend to always stay bunched up together, but yeah. Okay. Anyway, they kind of making sure the concepts are separated as much as possible. Then there's a score for making full logical sentences. There's a score for providing proper results, logical results. There's what else? Yeah, and subsequently, one after the other, they are being solved. So at the beginning, you solved a very easy one, and then you move to increasingly complex ones. Yeah, so it will not provide results that are not in the objective of that score, because it can't. It just can't. Okay. Then there's another way of seeing AI, I think, which is that of imagining it as a projection of the data you have. So we can make an analogous idea in photogrammetry. So 3D reconstructions. Imagine you have pictures of this area, okay, at this area. We have a lot of pictures from these ways, like from this point of view, several pictures of this area. So we can look at the design and we can reconstruct this scene in 3D, okay? I had a picture here, from here. Well, I can imagine what it would look like from here. And I can redraw this because I have some points of view. I can also imagine what it is looking at it from here, which is kind of outside of the usual points of view. So what you can do with AI, like you can consider AI models as extractors of the scene they are observing. In this case, we're talking about a place in 3D, like a place that we're looking at. In something like ChatGPT, you can imagine it as an information.
Do you think we are living in a simulation?
Not really.
Really?
Not really, no. I mean,
But it can be possible. Yeah?
Like
I believe 30
physics could be.
It's saying that mathematicians calculated some time ago. Maybe it's not right, but quite funny that 33% it can be possible that we are living in simulation.
There's a strong theory about how things work, which is I believe. Okay, let's put it this way. If is the most important thing that is in this expansion. If a free will exists, then there is inherent randomness in physics, and we basically are machines that structure information. Yeah, that's it. And the randomness is inherent. The randomness is inherent in quantum mechanical interactions, and the consciousness is the capability of deciding the result of those interactions.
I think the consciousness is something human, like emotions, the feeling. It's not like computational mathematics or numbers. It's just something.
I think I went too deep into my thing to think of it differently. I believe
something fundamental. I think.
Yeah,
consciousness is not something.
I think it's very dependent on.
It's really hard to calculate any consciousness. Like no one knows where it is.
Yeah, exactly.
No one knows where it's located. It's in the brain, or is it in the universe, or is it in dark matter, or
I am pretty strong with
God, or something. It's somewhere.
I believe it's quite continuous thing. And it's so interactions generate complexity. The more you have interactions that are not resolved into an actual observed decision, then that grows in that grows into the probability into being something more or less conscious. So
But, you know,
it's a lot about observation, I think.
if it's a simulation,
Yeah.
then you as an observer can simulate more complex things, you know, going deeper and deeper. You can the simulation can simulate even deeper levels, or if it's in microscopic, or even it's something further away. Like always, you can simulate galaxies, you know, in the computer screen.
There is a limit.
In an optical lens, you know, you can always simulate some
The photon
pictures, you know, like some images.
There is a limit.
Like it's not like it can be like independently. It's not there, but it's like just a simulated vision.
Okay. You mean you just perceive it, and
Yeah,
it's not really, that doesn't really exist. I mean, I can agree with that.
It's like the independent reality doesn't exist.
Yeah. I mean, it can be,
Like it's just in the head, in the brain.
or not.
You can,
Yeah, you can't.
It's really interesting how we switched
Yeah.
all this.
To AI.
Yeah, we started with armory and military segment. Then we spoke about that AI, and right now we are just discussing, how world works.
No.
Yeah.
But going back to the seeing things from a different perspective, that means that with a good enough AI system that is actually capable of extracting the information out of the data, because information is actually a there's actually a very small amount of information to the whole data that is available. Most of it is redundancy. Most of it can be predicted based on other data that is already available. The minimum boiling down of that is the actual information, right? The ideal AI model would be basically an information compressor, basically, that understands the data and turns it into raw information and allows me to see it from the other point of view. In most of the what does it mean, basically? In most of the data that we already have, we could just look at it and read it and study it, and it's possible to invent other stuff. But this stuff is not really invented, it's discovered out of something that we already saw, right? And that's the beauty of what we can achieve with AI models. Like what we would be able to reach with AI models. I think
but imagine like robots walking around like thousands or millions or billions, and then all these computers, you know, watching the reality and gathering all the information.
It's a Terminator scenario, right?
But like building completely.
there's the point.
Full picture of the.
See, the thing is, okay. There's a fundamental theory of there's a fundamental theorem in the theory of information that tells you that you cannot, like, processing information can only produce the same amount of information or less, which means that as long as but a robot could observe information, new stuff with the sensor. With sensor, it can observe randomness. So yeah. Okay, it can learn more stuff with sensors as long as it's not contained.
Consciousness somewhere, you know, like gathering everything, and then
as long as it's not contained,
it is adding more information to the whole.
Which, to my vision,
You can
means that a robot with vision. With vision and the capacity of choosing an objective can have consciousness. Can. But I think we get too far. At the moment, they're really only computation systems, so very 100% deterministic.
how do you Because
At the moment, just a commentary.
This deterministic.
but how do we know that we are conscious? There is.
I don't know. I mean, I think lots of people have been solving or answering that over several thousands of years of philosophy.
Yeah. It's hard questions.
Yeah.
No one knows. That's what is very interesting about the universe. Is there is so much unknown, so much that we don't know, don't understand.
I think at the moment when you understand everything, that's when there's no more information, and everything will just become boring or useless.
It's like
You know it already. If you know it, there's no more to discover. Therefore, there's no objective.
No.
You can explore the point of views, but that's it at that point.
What is the meaning?
Eh.
It's an information, right? So the meaning is information.
For me, yes.
Gaining more information, gaining more knowledge, understanding more.
For me, yes. But I think of information in a broader,
But what happens in the black hole? Information is lost, or is it stored somewhere? That's also like
black hole produces noise. Actually,
it's like
So
if you
it's one of
drop
the
inside the USB stick in the black hole, will it be lost, or will it be stored somewhere?
It produces noise though, and outputs. It actually produces noise. So everything that so in the theory of information, information is what out of the thing that I am observing, what I cannot predict, and I measure it in. I try to understand how complex it would be to predict that in terms of how many coin flips. Okay, and that's the way you measure information. Just find out if I had to predict something that is difficult to predict, that is random. How many coin flips would I have to do to have an equally difficult problem to just randomly guess? And that's the amount of information you get from observing something. Noise is the ultimate source of information, isn't it? So
It's like a matrix.
Yeah. But I mean, it's why can't it be a simulation? Yeah, it can be. Can be.
Yeah, it's very
It
interesting.
can be. But is it bad? No, I don't think so. Why not?
So many theories.
Although I think that whatever it is, we live in the system that we are, and
Hopefully, we will not get into war, like third World War, and hopefully we'll all live, survive,
I think
go further, and
I think continue developing things, make sure that the culture exists. Create value, basically, create value to stuff.
not destroying.
Yeah, but even in military terms, make sure that it's there for the purpose of protecting the creation of value. The
Military is pushing the boundaries of innovation.
yeah,
And that's this value. It will be.
I agree. Bullying. It's a weird talk.
Yeah. I think quite interesting. Like Romans before said, we went from the one side to the another, and quite interesting. The topics, and actually, and we can laugh about this Terminator thing. We don't know a lot of about AI. We can laugh about. But I understand that you are quite knowledgeable in AI, and when you start
When you understand something, it's not interesting.
Okay, but when you start doubting about this idea, it says, "Oh no, I will be scared right now."
I think the worst thing to be done in terms of at least in defense, if can cause a threat, then the bad idea is that of just ditching it, because somebody will use that. So you need to, like, if that thing exists, well, you need to understand it. That's it. Understanding is power in that case. That is true in any field. You know, when the nuclear physics arrived, understanding was necessary, because if the others ones understand and you don't, bad. Chemistry, same thing. If the other there's understanding and you don't, bad. Gunpowder. And if you go back, I don't know, like ships,
Right.
you know, if you don't understand it, that's when it's dangerous.
I guess it's coming to the finish line, right?
Final words.
Yeah, that was kind of really interesting discussion about. Started with a military segment, but as I said before, yeah, we ended about thoughts of how it works, and yeah, actually from there is such a more interesting ideas that we can discuss. Maybe how artificial intelligence will be in defense and military sector in a few years, but for this we'll need some more hours to speak, and yeah.
I think there's plenty of things, even extremely tiny problems that do not need to, like, that require a learning approach, because they would just be a bit too complex to describe in a computer program. That is a task for machine learning. You know, let's not call it AI in that case. The small models, let's call them machine learning. Like, use the statistical models to make sure that you have the highest possible reliability. And the interesting thing is that on small models, you actually can get higher reliability with a statistical model than the best you can do with a deterministic model. That's already applied to telecommunications, where, yeah, the best solution is made with a statistical model. Yeah. Because noise wins.
Okay. I guess we can finish on that.